Hello. Happy Earth Day. We're going to go over today vectors and parametric equations, the last topic in this unit. Sorry. Okay, a parametric equation is just an equation in terms of another variable, t. Usually it stands for time. So I'm going to look at a few of the examples from your practice. So write a parametric equation of this line. So this is an equation of a line. And so we're going to define x as t, just because that's the easiest thing to do. So x is t. And so then 9t plus y is -1. We're just going to replace x with t. And then solve this for y. So y is -9t minus 1. So x is t is the first thing in all of these. So that doesn't help me narrow this down. But I'm going to look for -9t minus 1. And so the answer is D. Okay, next. Here we're going the opposite direction. Here's a parametric equation. X equals 9t plus 2. Y equals -6t plus 9. We want to write the equation in slope-intercept form. So what we've got to do is we've got to figure out what t is, solve both these for t. So if I have x equals 9t plus 2, and I solve this for t, I'm going to subtract 2 from both sides, and then divide both sides by 9. So t is x minus 2 over 9. And then I'm going to do the same thing for my second equation. Y is -6t plus 9. I'm going to subtract 9 from both sides and then divide by -6. So t is y minus 9 all over -6. And then these two t's have to be the same. So x minus 2 over 9 is y minus 9 over -6. I just took these two and substituted it and set them equal to each other. Then I'm going to cross multiply. So -6 times x minus 2 is -6x plus 12. -6 times -2 is positive 12. And then 9 times y minus 9 is 9y minus 81. And then these are in slope-intercept form, so they're solved for y. So I'm going to add 81 to both sides. So -6x plus 93 is 9y. And then divide everything through by 9. And in this case, I'm going to have to reduce. So I'm going to get -6 over 9. Both of those are divisible by 3, and I get 2/3. So -2/3 x plus 93 over 9. Both of those are divisible by 3, and I get 31 over 3. And so y equals -2/3 x plus 31 over 3. The answer again is D. Okay, next, we just want to graph this. So I'm given this parametric equation, x equals -3 plus 9t, and y equals 7 plus 9t. And so in order to be able to graph this, I can either make a table, or in my opinion, what's easier is to change this into a point slope form function and then look for the graph. So I'm going to do exactly the same thing I did in the last one for the first part. So x equals -3 plus 9t. So I'm going to add 3 to both sides, and then I'm going to divide by 9. So t is x plus 3 over 9. And then do the same thing with y. Y equals 7 plus 9t. So I'm going to subtract 7 from both sides, and then divide both sides by 9. And t equals y minus 7 over 9. So x plus 3 over 9 equals y minus 7 over 9. Cross multiply, 9y minus 63 equals 9x plus 27. Add 63 to both sides, and let's see, is 90. So y equals x plus 10. Then divide everything through by 9. So it needs to have a positive slope. So C has a negative slope. It's definitely not that. It has a y-intercept of 10. y-intercept of 10 is here in B, sorry, and the slope there looks like it's 1. So it's B. There we go. Okay, I think I have one more. Let's check that one out. Write a vector equation that passes through the point -4, 11, and is parallel to this vector. Okay, so when x is -4, so we have, let's see. So x minus this x value, this would be the vector, so +4, and then y minus the y value, 11. So I'm writing a vector that goes from some point, that goes from P to some point x, y. We don't know what that point is, so I'm writing an equation of the vector, just like we did in the last unit. And that's going to equal t times this vector, -3, 8. This is how we do this in parametric equations. So if I distribute this t through, this is -3t, 8t. And so if this vector equals this vector, then x plus 4 equals -3t, and y minus 11 equals 8t. And then just solve them for x and y. So x is -3t minus 4, and y is 8t plus 11. And this is the parametric equation of the line. That's how we write it like that. This is the vector form of my parametric equation of the line. And so it goes back and forth between those two. Okay, well, that's it for parametric equations. Again, let me know if you have any questions with anything, and we can set up a video conference to go over anything. Take care.